Hey everyone, welcome back to my channel. Today we're going to dive into one of the most powerful concepts in machine learning, polynomial regression. We'll take a data set of employee salaries and predict whether the salary offered matches the position level. This example is often called the truth or bluff problem. By the end of this video, you'll understand what polynomial regression is, how it differs from linear regression, and how to implement it step-by-step in Python using scikit-learn. So let's get started. Step 1. Importing libraries. First, we import the essential libraries. NumPy for numerical calculations, Matplotlib for plotting and visualization, Pandas for handling the dataset. These three are the foundation of almost every machine learning project in Python. Step 2. Importing dataset. Next, we import our dataset position_salaries.csv. Here we extract x the independent variable, which is the position level, y the dependent variable, which is the salary. So we're essentially trying to learn the relationship between job level and salary. Step 3. Training linear regression. Before jumping into polynomial regression, let's try a simple linear regression model. We import linear regression from scikit-learn linear model, create an object linear regression, and fit it to our data. This gives us a straight-line relationship between position level and salary. Step 4. Training polynomial regression. Now, here's the fun part, polynomial regression. We import polynomial features from scikit-learn preprocessing. By setting degree equals 4, we're telling the model to include polynomial terms. This transforms our input features into higher dimensions. Then, we again use linear regression, but this time on the transformed features. Essentially, we've created a regression model that can learn curved, nonlinear patterns. Step 5. Visualizing linear regression. Here's the visualization of the linear regression model. The red points are our actual salary data, and the blue line is the prediction. You can see the straight line doesn't capture the pattern very well. The data clearly looks more curved. Step 6. Visualizing polynomial regression. Now compare it with polynomial regression. Here the blue curve passes through almost all the data points. This shows polynomial regression is much more powerful when the relationship is nonlinear. So in this case, polynomial regression models the salaries much better than linear regression. Step 7. High-resolution curve. To make the curve smoother, we create a finer grid of values using NumPy's arrange. This gives us a high-resolution curve that better represents the polynomial regression results. Step 8. Making predictions. Finally, let's make predictions. If we try with linear regression for position level 6.5, the predicted salary is around 330K. But with polynomial regression, the predicted salary is closer to 158K. Clearly, the polynomial model gives a much more realistic estimate. And that's how you implement polynomial regression in Python. We learned how linear regression fails with nonlinear data, how polynomial regression captures the complexity better, and how to visualize and predict using both models. If you found this helpful, don't forget to like this video, subscribe to the channel, and hit the bell icon for more machine learning tutorials. Drop a comment if you want me to cover more regression techniques, like support vector regression or decision trees. Thanks for watching, and I'll see you in the next video.